So far we've been talking about different tree structures, but let's talk about something completely different. Geocache or Z-order. From the name, it is clear that it is used in some navigational maps and geographical applications. So first of all, let me give some basic understanding of this. Imagine we have a grid of like 2 by 2 elements. We can present some mapping from 2-dimensional space into single-dimensional space by indexing each cell in this particular way, or for example, in this way, we can make it even more complex, like higher resolution, and provide some indexing, like is described on this picture. So we define some indexing rule. The rules on this picture are not taken arbitrary. So as you can see, the first one follows that shape. It is called Z order, and the one going in such I don't know how to call it, like almost rectangles, is called Hilbert curve. Generally speaking, that order or that curve and the Hilbert curve, those are the representatives of a big family of space filling curves. Space filling curves are specific type of curves which like fill all the available space. So they are like just going as you can compare that with sort of worms in a box, right? So they just fill all the space. It's first important feature, and the second important feature that having a curve as a mapping from single dimension into multiple dimension. All space filling curves has a property that close single dimensional parameters. They correspond to points close in multiple dimensional parameters. For example, if you have like index 4 and 5, it means that they will be close in cells in our grid, and index 4 and 15 will be further. That is a really important thing because, for example, this indexing can be used in different caches and stuff like that. So, for example, if you need to cache some textures for a map, nearby cells will be indexed with close index, and it means that cache hit probability will be high. As you can see, we can even like observe some generalization. So if we have high resolution, but we like reduce the resolution and consider this entire cell as one single cell, you can see that the complexity of the curve for each particular cell on higher level, it still follows the same pattern. And if you start generalizing more, the pattern will be preserved. So this is a specific of these particular curves. So as I said, this Z order or Z curve, it can be also mentioned in literature as Morton order or Morton code. The Morton code is mapping from n-dimensional space to a linear list of numbers. So how this Morton code can be calculated? The calculation is pretty straightforward. Okay, I don't like this because it squeeze rectangles, but okay, let me try to explain it. So let's imagine we have a 3-dimensional point like 591. We represent each coordinate in the binary way, and to build the Morton code, we interleave each bit in the final number. So we take the first bit of x-axis, put it here, take the first bit of y coordinate, and so we repeat the process. So we took all the first bits, then we take the second bits, third bits and the last bits. This way, we have some binary representation of a number which corresponds to something like this. Not that difficult, but has some obvious limitations. For example, if you use 64-bit integer to store Morse code, it obvious that we should limit just to 21 bit of of information that can be encoded into Morse code in this case. 1 bit can still be used for some custom flag of your choice, but still the range of coordinates is limited, and you need to consider that it will depend on what type is used for the code storage. Speaking about use case, so as I said, since that order is space filling curve, similar numbers represent close points in multiple space in 3D and 2D. But another thing is we can compare how points will be close to each other by comparing the prefixes, the common prefixes they have. So the longer prefix, the closer objects are. And taking into consideration another bit on the prefix, you can control the precision how you find the element. And another interesting point is that that order index is elements can be compared by that order and can be stored in regular binary trees, which simplifies the search process.